Hello guys, assalamu alaikum, bismillahir rahmanir rahim. Welcome back once again. I hope you all are best with your health. We are working on chapter 1 of grade 9. In our last lecture, we defined matrices, rows and columns, order of a matrix, equal matrices, and we did exercise 1.1. And today we are going to discuss a dozen of different types of matrices. So let's dive in. Types of matrices. First type is row matrix. A matrix having only one row is called row matrix. For example, A is equals to 1, 2, 3. See, what is the order of this matrix? 1 row and 3 column. This is row, 1 row and 1, 2, 3 columns. Columns doesn't matter. It may be 1, maybe 2, maybe 3, but row must be 1. So this row is 1. If row is 1, then it is called row matrix. See another example. B is equals to 2 and 0, 1 row and 2 columns. So this is also a row matrix. See another example. You can write 3. So 1 row, 1 column. So row is 1, so it is called a row matrix. Column is also 1. It can also be, we can also say this is a column matrix also. So let's define what is a column matrix. A column matrix having only one column. In row matrix, remember that it should be one row and column doesn't matter. But in column matrix, it should be one column and rows doesn't matter. Rows may be 1, 2, 3, but column must be 1. For example, A is equals to 1, 2, 3. So what is the order? 3 rows and column is 1. Since column is 1, so this is called a column matrix. For example, B is equals to 2, 0. The order is 2 rows and 1 column. And you can take C as any number. So for example, minus 3, 1 row and 1 column. So this is row matrix also and column matrix also. So like this you will define row matrix having 1 row and column matrix having 1 column. In row matrix, column doesn't matter, and in column matrix, row doesn't matter. Next is square matrix. In a square matrix, number of rows must be equals to number of columns. Then it is called square matrix. For example, we have a matrix A whose elements are 1, 2, 3, 4. Another example, we have B. B has elements 0, 1, 2, 3, 4, 5, 6, 7 and 8. This is also a square matrix. So what is the order of A? 2 into 2, 2 rows and 2 columns. So number of rows and number of columns are same. You can see here we have 2 number of rows and 2 number of columns. So 2 into 2. What is the order of B? Order of B also is same. Number of rows are 3 and number of columns 1, 2, 3. Number of columns also 3. 3 into 3. So the order of B is also same. So what is a square matrix? In a square matrix, we have number of rows equal to number of columns. You can see the order must be same. If order is not same, then what will happen? Then it will be a rectangular matrix. So I will write its definition. Number of rows is not equals to number of columns. For example, we have a matrix C whose elements are minus 2, 0, 1, 1, 2, 3, for example. Any number you can take. So what is its order? Its order is 1 and 2, 2 rows. First you must write rows, number of rows, then you need to write column. 1, 2, 3, so 3 columns. So 2 into 3 is the order of C. Let's see another example. D is having elements 1, 2, 3 in the form of a column. Now what is the order of D? D is having order 3 rows, 1, 2, 3, 3 rows and 1 column. So 3 into 1 is the order of D. You can see number of rows are not equal to number of columns in both cases. So if number of rows are not equal to number of columns, then it is called a rectangular matrix. Next is null or zero matrix. Null or zero matrix is a matrix in which all elements are 0 and it is denoted by capital O. For example, the entries are all elements are 0, 0, 0, 0 and 0. So this is a null matrix. You can say, let's see another example of null matrix. It is denoted by O and you can write 1, 0 inside also. This is also null matrix. In null matrix or zero matrix, order doesn't matter. You may have 2 into 2 order, 1 into 1 order. It may be square matrix or it may not be square matrix. For example, 0, 0. This is also a null matrix. And its order is 1 into 2, 1 row and 2 column. So what is a null matrix? All elements are 0. Negative of a matrix. Let's say there is a matrix A whose elements are 1, 2, 3, 4. Then negative A is called negative of a matrix. When you multiply with minus the sign of all elements you need to change inside the metric, then it is called negative of a matrix. Let's see another example. If you have B, another matrix 1 and 2, so what will be negative B or minus B will be minus 1. If 2 is already minus, you will make it plus. So just you need to multiply negative inside with each element, with each and every element of the matrix. Then it is called negative of a matrix. The plus will become minus and the minus will become plus. So this was negative of a matrix. In null matrix or negative of a matrix, the matrix may or may not be a square matrix. It doesn't matter it is square or not. For example, the order of A is 2 into 2 and the order of B is 1 into 2, 1 row and 2 column. So it's not necessary it must be square. So next type is transpose of a matrix. So how to find a transpose of a matrix? This you will understand with the help of one example. Let's say A is a matrix whose elements are 1, 2, 3, 4, 2 by 2 matrix and its order is 2 into 2. The transpose of A is denoted by A raised to the power T and is defined as by interchanging rows into columns. So this row 1, 2 change into column 1 and 2, 3 and 4 are the elements of row change into column 3 and 4. So this is called transpose of a matrix. So how we will get transpose of a matrix? By interchanging either rows into columns by either interchanging rows into column, or only one you need to change, then don't change both, or columns into rows. Let's see another example. B is having 1, 2, 3 elements. Its order is 1 row and 3 columns. 1 row and 1, 2, 3 columns. So what will be B transpose? B transpose is denoted by B raised to the power t, and this row we will write in the form of column 1, 2, 3. One, two, three. What will be the order of B T, that is transpose of B? Order will be 3 into 1. So rows will become columns and columns will become rows. So you can see here what is the order of B. Order of B is 1 into 3, and what is order of the matrix B transpose is 3 into 1. Order will also interchange. Rows will change into column and columns will change into rows. So when you take the transpose of a matrix, order will also interchange. So next type is symmetric matrix. A square matrix A is said to be a symmetric matrix if A transpose is equals to A. Means if you take its transpose, then it will be the same matrix A. Let's see example. A is a matrix whose elements are 1, 2, 3. This side also write 1, 2, 3. Rows also, column also you should match. So if second row is 2, 5, 6, here also write column also 2, 5, 6. And 3, 6, 7 if you are writing is okay. So for symmetric matrix, it must be a square matrix. So what is the order of this one? 3 into 3. If you take its transpose, what will be its transpose? A transpose will be this row, change this row into column, so it will be 1, 2, 3. Change this row 2, 5, 6 into column, so it will be 2, 5, 6. Change this row into column, so it will be 3, 6 and 7. Now you can see this is the same matrix A. So A transpose is equals to A. So this A is called symmetric matrix. The order of A transpose is also same, 3 into 3. It is important for the symmetric matrix, it must be a square matrix. If it is not square, then it will not be equals to A. It will not be symmetric matrix. For example, there is a matrix B, its elements are 1, 0 for example, and what will be its order? Its order is 1 row and 2 column, and B transpose will be equals to, how to take the transpose? You are changing the row into column, 1 into 0. 1 and 0 will be its B transpose. You are changing row into column. So you can see B transpose is not equals to B. Why? Because its order is not same. The order of B transpose is 2 into 1. Why order is not same? Because it is not a square matrix. So it must be a square matrix. If it is not a square matrix, then it will not be a symmetric matrix. Now one thing, how you will take the example of a symmetric matrix. For example, I am writing 1, 2, 3. The same numbers, whatever numbers you have taken in rows, take the same numbers in column. Like 1, 2, 3 rows and 1, 2, 3 column. These 3 numbers I have taken in the row, same numbers take in the column 1, 2, 3. Now second row I am taking 2, 5, 6 for example. This row I have taken 4, 5, 6 as a row. Same number take as a column also, 2, 5 and 6. So you will write here 6. The last number doesn't matter anything, you can write. So when you take its transpose, it will come same. If you will not take same like this, then transpose will not be equal to A. Then it will not be a symmetric matrix. For example, 1, 2, 3, 5, 6 and 7, 8. Now if you take its transpose, what will be A transpose? A transpose will be 1 change row into column. So this row change into column 1, 2, 3. This row change into column 2, 5, 6, and this row change into column 3, 7 and 8. Now you can see this is not equals to A transpose is not equals to A. So this will not be a symmetric matrix even if it is a square matrix. Okay. Next is skew symmetric matrix. It must be a square matrix, and the condition is when you take its transpose, A transpose is equals to minus A. When this condition will satisfy, we will say it is a skew symmetric matrix. Let's see the example. For example, so how you will memorize the example of skew symmetric matrix. See, A is a matrix, like how you will take, right here the diagonal elements you take 0. Okay, 0, 1, 2, same row like as a column 0, 1, 2 also, and I told you main diagonal, this is called the diagonal. This diagonal takes 0, 0, 0. Now whatever you will take a row 0, 1, 2, take this one also same 0, 1, 2. Next row is 1, 0, for example 3 here, so right here also 1, 0, 3. This also will come 1, 0, 3 for symmetric matrix. Okay. Now you can see 0, 1, 2, 1, 0, 3 I have written here and 3 here. This is a matrix A. Now write here minus also, minus 1, minus 3 and minus 2. Now take its transpose. So A transpose will be equals to, you need to interchange the rows into columns. So 0, 1, 2, minus 1, 0, 3, similarly minus 2, minus 3 and 0. Now take minus common. When you take minus common from each element, the sign of each element will change inside the matrix. The negative numbers will become positive and positive numbers will become negative. 0 is neither positive nor negative, so write as it is. This minus 1 will become plus 1, minus 2 will become plus 2. This 1 will become minus 1, 0 as it is, minus 3 will become plus 3. Similarly 2 and 3 will be minus 2 and minus 3 and 0 as it is. Now you can compare this one with A. This is same matrix as A. 0, 1, 2, 0, 1, 2, minus 1, 0, 3, minus 2, minus 3 and 0. So we can write A instead of this matrix. So A transpose is equals to minus of A, negative of A, you can say. So we can say A is a skew symmetric matrix because it satisfies this condition. A transpose is equals to minus A, and it's a square matrix also. Order is 3 into 3. Number of rows are equals to number of columns. Next is a diagonal matrix. A diagonal matrix must be a square matrix first of all. So let's take for example a square matrix of order 3 into 3. For example, I am taking this one, 3 0 0 0 0 0, this also 0. This is called this middle entries or middle elements. These are called diagonal elements or diagonal of matrix. So it is a square matrix of order 3 into 3. So first condition satisfied. Second is at least any one element of its diagonal is not 0. So there are 3 elements in the main diagonal. I wrote 3 0 0. So one element, this one element 3 is not 0. The other 2 are 0. At least one means one element should not be 0. All 3 can be 0, no problem, but at least one should not be 0. If all will be 0, then it will be a null matrix or 0 matrix. So at least one element should not be 0. See other examples also. I am writing 2 2 0 here, and these are called non-diagonal elements. Third condition is non-diagonal elements must be 0. These are called non-diagonal elements. So non-diagonal elements are 0, and the diagonal elements, these are diagonal elements. Here at least one is 0, here more than one are non-zero, here 3 is non-zero. So at least one element is non-zero in the first example. In second example, I have written 2 2 0 in the diagonal. So more than one are non-zero. I can also write like this one, 3 3 3 0 0 0 0 0 0. This is also a diagonal matrix. All elements may be same also, no problem. I can also write I can also write 1 0 0 0 1 0 0 0 1. So this is also a diagonal matrix. Okay. So it must be a square matrix. All are square matrix. At least any one element of its diagonal is not 0. One element should not be 0. The others 2 can be 0. All should not be 0. If all 0, then it will not be a diagonal matrix. It will be a null matrix. You can also write like 1 2 3 0 0 0 0 0 0. This is also a diagonal matrix. All elements in the diagonal are different. It can be same also, it can be 1 also. Further, we will classify if it is same, it will be a scalar matrix, and if it will be a 1, it will be identity or unit matrix. But all diagonal matrices are, but all these are diagonal matrices. Hope you understand diagonal matrix. Next is scalar matrix. A scalar matrix should be a diagonal matrix. Diagonal matrix means it should be a square matrix, and diagonal elements are same, but it should not be 0 and 1. What is the meaning of this one? For example, there is a matrix whose elements are -2 0 0 0 -2 and 0 0 0 and -2. You can see the elements of main diagonal are same. So it must be a diagonal matrix. So it's a diagonal matrix. All non-diagonal elements are 0. You can see here. And the main diagonal elements are same. All are same, -2 -2 -2, but not 0. if you will write all 0, then it will be a null matrix, and if you will write 1 here, then it will be identity matrix. Other examples of scalar matrix, you can see 3, 3, 3, 0, 0, 0, 0, 0, 0 here. So if the diagonal is same, then it is called a scalar matrix, but it should not be 0 and it should not be 1. Why? Because if it is 0, it will be a null matrix, and if it is 1, it will be identity matrix or unit matrix. You can also write A 0 0 0 A 0 0 0 A. This is also a scalar matrix, and this A should not be equals to 0 and A should not be equals to 1. Why 0? If A is 0, it will be null matrix. If A equals to 1, then it will be identity matrix. But scalar matrix must be a diagonal matrix. It means it must be a square matrix also. Next is identity or unit matrix. Similarly, like scalar matrix, identity matrix should also be a diagonal matrix, and if it is diagonal, it must be a square matrix, and all diagonal elements are 1. For example, 1 0 0 0 1 0 0 0 1. So this is a identity matrix or unit matrix. It is denoted by I. If you write 1 also, this one is also identity or unit matrix denoted by I, because it is a diagonal matrix. It's a square matrix. Order is 1 into 1. Here order is 3 into 3. But if you take this one 1 0, this is not diagonal or identity matrix. This one is not identity matrix. Why? Because it's not a square matrix, it's not a diagonal matrix. So main diagonal elements must be 1, like this. Similarly, 1 0 or 1 0 more you can put. This one is also not identity matrix, because its order is 3 rows and 1 column. It must be a square matrix. Okay guys, so far we have learned 12 types of matrices. Remember this point in your mind: every diagonal matrix is not a scalar or identity matrix, but every scalar or identity matrix is a diagonal matrix also. Obviously, see this example: 1 0 0 0 2 3 0 2 0 0 0 and 3. The diagonal elements are 1 2 3. It's a diagonal matrix. It's not scalar and not identity matrix. Now this one 2 0 0 0 2 0 0 0 2. This one is a scalar matrix and diagonal also. 1 0 0 0 1 0 0 0 1. This is identity matrix and diagonal also. So all diagonal matrices like this, all diagonal matrices are not scalar or identity, but all identity or scalar matrices are diagonal matrix. Okay guys, now let's do exercise 1.2. Question number 1 is: from the following matrices, identify unit matrices, row matrices, column matrices and null matrices. First of all, look at A. All elements are 0, so it's a null matrix. So you can write here A. A is a null matrix because all elements are 0. It should be denoted by O anyhow, A also okay. B, you can see B is a row matrix because there is only one row. So B you can write here. Check number of rows and number of columns here. number of rows is 1 and number of columns are 1, 2, 3. So it's a row matrix. C you can see there is one column only and 3 rows are there, 1, 2, 3. First you need to write rows and then column. So if it is one column, it is a column matrix. D is a square matrix and diagonal element is 1. So it is identity or unit matrix. You can write here D. You know identity matrix is denoted by I also. Next E. E is obviously 0. So null matrix, you can say. Its order is 1 into 1. So you can write this one as row matrix also and column matrix also, because it has one row and one column. F is again a column matrix because its order is 1 into 3, 1 column and 3 rows. And you know if there is column is 1, it is called a column matrix. So F in the column matrix here. Let's do question number 2. Question number 2 says that from the following matrices, identify square matrices, rectangular matrices, row matrices, column matrices, identity matrices and null matrices. So first one is, you can see 2 rows and 3 columns. 2 rows and 3 columns. So number of rows are not equal to number of columns, so we can say it's a rectangular matrix. So you can write here this belongs to B. Part 2 is also, you can see it's making a rectangle and the order is 3 rows and 1 column. So you can say, because it's 1 column, so you can say it's column matrix also and rectangular matrix also. So this one is B and D also. D is column matrix and B is rectangular matrix, because number of rows are not equal to number of columns, so it's rectangular matrix and column matrix because it has only 1 column. Part 3, 2 rows and 2 columns. Number of rows are equal to number of columns, so it's a square matrix. You can write here A. Number 4, the diagonal is 1, so it's identity matrix, so you can write here E. 4 is also a square matrix because number of rows equals to number of columns, so you can say A also here. Three rows and 2 columns, 3 into 2, so it's a rectangular matrix, so you can write here B. Number 6 also rectangular, 1 row and 3 columns, 1, 2, 3. It's rectangular also, B, and since it has 1 row, so it has row matrix also. It is row matrix also. Number 7, we have 3 rows and 1 column, so you can say it is column matrix D, and it is rectangular also B, because order is not, the number of rows is not equal to number of columns. Number 8, 3 by 3, 3 rows and 3 columns, so it's a square matrix, so you can write A. Number 9 is all elements are 0, so it's null matrix, so number F. And the order of part 9 is 3 rows and 2 columns, 3 into 2, so you can say it is a rectangular also, so you can add B here also. Next is question number 3. From the following matrices, identify diagonal, scalar and unit or identity matrices. So you can see A. So diagonal is same, 4 and 4, so this one is scalar matrix. Here the diagonals are not same, so this is only diagonal. Here diagonal is 1 and non-diagonal elements are 0, so this is identity matrix, or you can say unit matrix. Here you can see 3 and 0 and non-diagonal elements are 0, so at least one element of the diagonal is non-zero, so this is also diagonal matrix. E you can also write 5 minus 3 is 2, 0, 0, 1 plus 1 is 2, so diagonal elements are same, so it's mean it is scalar. So this was question number 3. Question number 5 is find the transpose of each of the following matrices. So what will be A transpose? Transpose means this column you need to change into row 0, 1 and minus 2. Interchange column into row or row into column. The order of A is 3 into 1 and its transpose order is 1 into 3. So in transpose, order will also interchange. What will be B transpose? This is a row, change into column. So 5, 1, minus 6. It's not necessary to write order, but I am writing so that you will see it will also interchange. So 1 into 3, 1 row and 3 columns, and here we have 3 rows and 1 column. Similarly, C transpose will be equals to, let's write here, this row will change into column 1, 2, this row will change into column 2 into minus 1 and 3, 0. So order of C is 3 rows and 2 columns. Order of C transpose is 2 rows and 3 columns. Similarly, D transpose will be equals to, this row will change into column 2, 3 and 0, 5. This is D transpose. Because it's a square matrix, so will not have any effect on the order. E transpose will be equals to, this row write in column 2, 3 and this row also write in column form. So this will be E transpose. Similarly, F transpose will be equals to F raised to the power T, which is the notation for transpose. So 1, 2, the row will interchange into column, and this 3, 4 will change into column. So this is F transpose. So this was question number 5. Now let's do question number 6. Verify if A equals to this, B equals to this, then find A transpose, the transpose of A transpose equals to A, and the transpose of B transpose is equals to B. Means if you take twice the transpose of a matrix A, then it will be equals to A. Similarly, if you take the transpose of B twice, then it will be equals to B. So let's take A transpose. A transpose equals to, this row will go like this, will become column, and this row will also become a column, second column. Now again take the transpose of A transpose, double transpose, you will write like this. Now this row you will change into column, and this row you will change into column 2, 1. Now what is 1 2 0 1? It's same A, this one. So A transpose of, the transpose of A transpose is A. So we have verified. Similarly, take the transpose of B, which will be B transpose. So this row change into column 1 1, this row change into column 2 0. Again take its one more transpose of B transpose. So this row change into column, this row change into column 1 0. You can say this one is same as B. So the transpose of B transpose is B. So we have verified this one also. So that's it. If you have any question, please don't hesitate to ask me. Thank you very much. Have a nice day. See you in the next class, inshallah.